Hello, my math friends. This is Mrs. Schlecht. And in this video, we are going to be solving some inequalities with addition and subtraction. All right, so you know that before we get going, there's a few materials that you need in order to be successful for this activity. First, you're going to need your Envision book. Remember, we're in volume 2 now. Second, don't forget your math notebook so you can take great notes and show all your wonderful math thinking. Third, don't forget that pencil to take those notes. And fourth, last but certainly never ever least, that positive math attitude. Well, my friends, this video goes very well with lesson 5-4 in your Envision Volume 2 book, of course. The key concepts can be found on page 286. Now, what we're talking about is inequalities and solving those using addition and subtraction. But before we get into all the fun math problems that we're going to do, let's just do a quick little review about inequalities. All right, quick inequality symbol review, okay? Now remember, we have the equal sign. It's not on this list, so don't go searching for it. It's not there. But equal means it's the same, right? It means that this side of my equation and this side of my equation, those are the same. Those are balanced, all right? Inequalities mean that it's not always the same, okay? So we have these different symbols. This isn't in your book, but it should definitely find its way into your math notebook. Hintity hint, hint, okay? All right. So the first one, we have our Pac-Man little mouth pointing, opening that way. This is less than. So we could say that 5 is less than 7. That's how we would read that, okay? Next, we have a less than sign, but notice it has a little bar underneath. It's like part of an equal sign, okay? So we would say this is less than or equal. And we use this a lot with variables, okay? So in this case, I'm saying that x, that's our mystery number, not sure what it is, but it's either less than or equal to 5. So it could be 5, but it might also be like 0, 1, 2, 3, 4, or anything under 5, okay? Next, we have greater than. So notice our symbols have flipped, okay? Greater than. So our Pac-Man mouth is open in the other way. So we could say that 7 is greater than 5, right? 7 is greater than 5. That's the symbol we use for that. Now our other symbol, still greater than, but again, notice it has that little bar underneath. Or equal, that's the option, right? So it's either greater than or equal. So again, we're talking about a variable x, don't know what it is, but if I'm saying that it's greater than or equal to 7, it could be 7, but it could also be 8, 9, 10, 11, 12, infinite numbers, right? And then lastly, we have the not equal sign. So it looks just like a regular equal sign, but it has that line through it that's showing us it's not equal, okay? So in this case, we could say that 7 is not equal to 5. Those are not the same value. You might also have it with a variable where it might say like x is not equal to 5. So we don't know what x is, but we know it's not 5. All right. So again, please make sure that this is written down in your math notebook. Now let's get into some math problems, my friends. All right, my friends. So the first problem that we're going to be looking at together is on page 287, number 6. Now, x plus 5 less than 7. All right. We're going to try to figure out what x is. But real quick, you'll notice that we're using something called inverse operations. And really, my friends, it's just the opposite. So I always think to myself, well, how do I undo the math? How do I undo what's happening here, right? You use the opposite. What I mean is, I took x, don't know what that is, it's a mystery number, right? And then I added 5 to it. How do I undo adding by 5? Well, you subtract 5, right? So addition and subtraction, they're the opposite of each other. So you use those to undo the other one, right? And that's what this lesson is talking about. So whenever you see inverse operations, I would definitely put this in your notebook, FYI, because your test will, have that information. So FYI, I'd put that on there, okay? But inverse operation, again, just means the opposite, okay? So if we're thinking about that, in this inequality that we're trying to solve, what we're trying to do, my friends, is get to the point where we could say x is less than something, okay? So we're going to keep working through this. Kind of ignore this inequality sign first. Let's just work through it, try to figure out, get x all by itself, isolate our variable. That's what we're going to do, try to get x all by itself so we can figure out what x is less than, right? But remember, we're going to undo this addition by using subtraction. So let's look at this problem. Again, we have x plus 5 equals 7. So I'm going to keep this inequality sign. It's not going to move. It's not going to flip. We're just going to leave it the same. Pretend it's an equation, just like a regular old equation with an equal sign. We never changed the equal sign, right? The equal sign just continued. So stay with me on that, okay? But how do I undo adding by 5? We subtract by 5. So because we want to keep this balanced, we need to make sure that if we subtract 5 from this side, we also need to subtract 5 from this side. So when I subtract 5 from each side, well, adding 5 and then subtracting 5, that just cancels each other out. And I represent that, but I'm just going to draw a line through it. So now this piece is no more, and that's how I have x all isolated, all by its lonesome, right? Just chilling over here. Again, we kept that same inequality sign, that same less than sign, because we're not changing the meaning of this problem at all, right? And you'll notice on this side of our inequality, we now have 7 minus 5. Now that's math we can actually do, right? So what is 7 minus 5? It's 2. So we now know that x is less than 2. I don't know what x is. It could be 1/2, it could be 1/4, it could be -50, it could be 1, it could be 1.99, right? As long as it's less than 2, this inequality will be correct. You'll notice there's a second piece to these problems where it actually asks you to graph this answer on a number line. Let's have fun with that. My friends, I present to you a number line. Ooh, notice negative numbers over here, 0, positive numbers over here, okay? So what we're trying to do is I want to graph x is less than 2. I want to graph all of the numbers that this could represent, okay? Now, x is what we're trying to figure out, right? But 2, positive 2, that's our only frame of reference. That's our only location, all right? So what I'm first going to do is I'm going to draw a circle above the number 2. So, my friends, now on this number line, we have graphed all of the solutions, or at least some of the partial solutions, to what the value of x could be, right? With x is less than 2. So because 2 is the only number that we actually have right here, that's our point of reference, right? That's the one relationship that we actually know about. I know that x is not 2, right? That is why this circle is not colored in. If you go back a couple seconds ago, we talked about all of those different inequality signs. And remember, there was a less than or equal to option, but it is not this, my friends. And because it's not this, that circle is going to remain open because 2 is not x. X is not 2, right? X needs to be tinier than 2. That's why, again, that circle is open. And then notice that this blue line on our graph is pointing away from 2 towards all of the numbers that are smaller than 2. So what this represents is that our mystery number, it's less than 2. It's not 2, it's less than 2. So what we did is we solved this original inequality. We used that inverse operation by taking the addition and subtracting it to undo it. We discovered then that our variable x needs to be less than 2, and then we graphed that solution on a number line. All right, my friends, so the next inequality little fun that we're going to have is with problem number 8 on page 287. So same sort of setup, right? We have an inequality. Ta-da! We got to solve it, then we are going to graph it. One thing I'd like to point out, look at our inequality sign. Yes, it's greater than or equal to. That or equal to part going to come into play later, okay? So just take a note, little mental note of that we have a greater than or equal to, right? That or equal to. Last problem we did, equal to, not an option. Not an option, my friends. Not an option at all. This time, possible option, okay? So, little thing, okay? So our inequality, we have x, which is what we're trying to figure out. X plus 10 is greater than or equal to 14, all right? So this means that when we actually do this, x plus 10 could be 14, 15, 16, 17, 18, a kabillion, right? So now, again, we need to think about that inverse operation, that opposite, right? So how do you undo adding 10? You subtract 10. And remember, whatever you do to one side of your inequality, you also need to make sure that you do it to the other side of your inequality as well. Now we have solved this inequality, right? So we started with x plus 10 is greater than or equal to 14. How do we undo adding 10? What's that inverse operation? Subtraction, right? So we subtracted 10 from both sides. Remember, when you add 10 and then you subtract 10, that cancels each other out, right? So that's just gone, okay? So then we have that x is greater than or equal to whatever the answer to 14 minus 10 is. Again, remember, we're just keeping that same inequality. We're not switching it. We're not changing it up or anything like that. It's staying the same. I do know that 14 minus 10 is 4. So this tells me that x is greater than or equal to 4. X could be 4, but it could also be 5, 6, 7, 8, 9, 10, a kabillion as well, right? So if x is greater than or equal to 4, how would we graph that on a number line? Another number line, my friends. Ooh, so nice. So I do have a couple of negative numbers here. Remember, the arrows on this number line just mean that it extends forever and ever and ever and ever and ever and always, right? It's just like a small little snapshot of it, okay? So again, 4 is the only like point of reference, right? The only location that I really know about. So that's why the circle is right above the 4. But you'll notice it's now shaded in. Why, Mrs. Schlecht? Why did you decide to color? Because art is very beautiful, my friends. No, besides that, it's because it has that or equal to option, okay? So that last problem we did, or equal to, was not an option. That's why our circle stayed open. It was not colored in. This is what we call a closed circle, my friends, a closed circle. And it's closed because of that or equal to option, okay? So 4 and x, it might be equal, it might be the same, but x also might be anything bigger as well, right? So how do we represent that? We have a closed circle that represents that or equal to possibility, but then that arrow is pointing to all the numbers that are greater, that are larger than 4 to represent that x is greater than, that's the greater than part, or equal, that's the closed circle part, to 4. All right, my friends, so that was just a quick run through over solving these inequalities with addition and subtraction. As always, if you have any other questions, please let me know.